you. I am Ella, welcoming you all on behalf of Solar Water Africa and the First View Group to the Microgrid Strategies and Energy Storage Solutions for Resilient Power Supply in Remote and Harsh Environments webinar powered by Jinko ESS. Before we proceed further, I would like to thank our panel members for their immense support to organize this event and extend my heartfelt gratitude to our sponsor, Jinko ESS, for being our crusaders and making this event possible. Their commitment to promoting sustainable energy solutions is truly commendable. I would now request my team to play the commercial video for Jinko ESS. Thank you, team. May I now invite Mr. Titus Koek, Senior Technical Service Manager, Jinko ESS, to give the presentation for his company. Over to you, sir.
Thank you so much, Ella. I'm hoping you can hear me clearly. So allow me to share my presentation. Yeah, good afternoon, ladies and gentlemen. I must say that it's really an honor for me to present on behalf of Jinko Solar today. And as mentioned, my name is Datis. The technical service senior manager for Jinko Solar Sub-Saharan Africa. And my presentation is actually going to be a technical commercial presentation on Sangika for microgrid applications in Sub-Saharan Africa. And just to start off with is just to introduce my company, to say that Jinko is actually one of the global leaders of PV modules and also battery energy storage. We've recently, as of Q1 of 2021, of 2024, sorry, we've actually managed to deliver more than 225 gigawatts of PV modules. And our most recent achievement was in Q2, start of Q2, where we actually listed as a tier one battery energy storage manufacturer by Bloomberg New Energy Finance. On the PV module segments, we currently, have a capacity, an annual capacity of 120 gigawatts, and also a cumulative market share of a global market share of 15%. And as a manufacturer, we've also segmented our PV modules portfolio into two main products, or rather series of products. That is the Tiger Pro, which is the P-type modules, which we basically going to phase out most probably by the end of 2024. And we also have the famous Tiger Neo, which is Tiger Neo modules with power class ranging from all the way to 425 and from 425 all the way to 650 watt peak. That is for different applications. And apart from that, is that we've also, like I said, we are also an energy storage manufacturer as well, and with different solutions that is for different applications, including one residential applications where we have our residential energy storage solutions. That is basically solutions less than 50 kilowatt hours. They get it as the sun tank. We also have the commercial and industrial energy storage solutions as well that we also provide with capacities ranging from 50 kilowatt hours all the way to 2 megawatt hours. And this can either be liquid cooled and also air cooled as well. I'm going to give the differences later on. That is basically the Sun Giga. And lastly, we also have solutions as well. That is for utility applications. That is megawatt scale up to hundreds of megawatt hours, up to gigawatt hours as well, which comes usually in containers of that is 20-foot containers and can have different standard sizes of 3.44 megawatt hours. We can also have 3.72 megawatt hours, 3.76 megawatt hours, and also 5.01 megawatt hours as well. And we've also, we've taken some bit of time to also build up into our production lines as well. We have a very big, massive production facility in Naining, China, and with a total production capacity of 12 gigawatt hours. That is annual capacity of 12 gigawatt hours. This is where we actually doing our that is our pack assembly and also the integration that is for our Santera and also the Sun Giga units as well. And just to get back now to introduce our today's topics, which is basically mainly focusing into microgrids, the different strategies, and also the solutions for resilient power supply. It's I think it's prudent enough for us to understand on what is basically a microgrid. So I'll briefly maybe define a microgrid as maybe a group of electrical sources and also loads as well that would basically operate with or without grid, that it can actually operate in an on grid or also in an off grid scenario as well. In some instances, we can say that it can also operate in an islanding mode. And the good thing about microgrid is that it can actually be a combination of different energy sources, which can either be renewable and also non-renewable as well. When it comes to renewable, which in this case we are mainly focusing into solar, wind, and also with a combination of different battery or other energy storage systems, which can include what we are focusing on as Jinko, which is basically battery energy storage systems. The good thing about microgrids is that it gives an alternative of one, you can say, flexible and resilient solution for improved energy access, especially if we want as a continent to be able to increase our energy access, and also we would want to have there is energy access to reliable and also affordable power as well. And the other thing that also wants to look into, for the past few years, like I said, battery energy storage systems have mainly been applied in the main applications in sub-Saharan Africa is mainly for microgrids. But despite this very good success for the past few years, the different battery energy storage solutions have actually faced a number of challenges. And I've just highlighted into 6 main challenges, which would include one, the environmental conditions, that is the very harsh environmental conditions. We know that a massive part of sub-Saharan Africa, or rather the whole of Africa at large, usually experiences extremely high temperatures. There is high dust concentration as well. We also have humidity as well, which basically would affect the longevity of the battery energy storage systems. We also have other challenges as well, including infrastructure, which is most of the microgrid solutions that we have in the region, whether mini grids or even some microgrid as well, you'll find that they usually have this in remote areas with no proper transportation route as well. So makes it very difficult to transport materials and also labor as well. And also other factors including viability, that is the financial viability as well, which is basically requires huge capex and also opex as well. And the other key challenge that we've also seen in the region is, I would say, basically the lack of the relevant technical expertise when it comes to that is installation, when it comes to the design, and also when it comes to the maintenance of battery energy storage system as well. That is where now there is different parties, government institutions, private entities as well, and also OEMs are also coming in to ensure that there is basically proper training, proper knowledge transfer to make sure that we empower local communities and also professionals so that we can improve on the operation, or rather on the uptake of battery energy storage systems. And as a manufacturer, as an OEM, as Jinko, we've actually analyzed critically on the different challenges, and we've come up with solutions to be able to address most of these challenges. And ideally today, I'm not going to talk into the whole portfolio about Jinko, but I'm mainly going to focus into the SunGiga solutions for microgrid applications, which is basically has two main components. One is the power conversion system, which is outdoor. It is IP55. We also have the battery cabinet as well, which is also IP55 as well. That is for outdoor applications. And just to show you on basically how the DC cabinet, the battery cabinet will look like. It's actually a 1.3 by 1.3 by 2 meters, 2.3 meters height. That is DC cabinet, and the cabinet has the cabinet has a number of batteries, which can either be 5 batteries or 8 batteries. With 5 batteries, we can have 215 kilowatt hours. With 8 batteries, we can have 344 kilowatt hours as well. And it works in the principle of liquid cooling. This is actually a technology, a liquid cooling technology that I'm going to explain in my next slide. And you see, with the different capacities of 344, we can have a voltage range of more than 1,000 and less than 1.5 kilovolts. And also, we can have there is a lower voltage range of less than 1,000. That is basically between 672 to 864. We usually promote this 215 mainly in the African region because of compatibility with most of the power conversion equipment, which is basically less than 500 kilowatts. So you'll find that the battery operating voltage range is usually less than 1,000 volts. That is why we usually promote this for most of the microgrid applications in sub-Saharan Africa. And the thing is that just to understand on what is liquid cooling. Like I mentioned before, one of the main challenges when it comes to battery energy storage systems is basically the harsh environmental conditions, which includes extremely high temperatures. So we basically needed to have an effective cooling system. And liquid cooling is basically an advanced cooling system which allows flow of the cooling, or rather the cooling agents, which in this case, as in Jinko's perspective, is actually a mixture of water and glycol. That is 50% water and 50% glycol to flow into cooling plates that is directly connected to the battery packs. So this is basically allows to ensure that this allows efficient heat dissipation from the battery cells, that is to the cooling agent. And of course, we have a central cooling system that I'm going to show you in the next few slides. Then, of course, the coolant is going to flow into each of the battery cooling plates that is attached to each of the each of the battery packs. And the other thing is that if you look into the structure of the DC cabinet, like I mentioned to you, that the main components of the Sun Giga for microgrid applications is one, the PCS that I'm going to mention later on. Then we also have the battery system. So for the battery system, the main components basically the batteries, the battery packs, which can either be 5 or 8. Each battery pack is 43 kilowatt hours. So if we have 5, that makes it 2 and 5. If we have 8, then that makes it 344. They're all connected in series, and the final termination is actually on the high voltage box. Then we also have the battery management system, or rather the BMS, which is basically two-layered. There is one, the first layer is the battery management unit. Then we also have the second layer, that is the battery cluster management unit on the high voltage box. Then we also have the cooling system, that is the cooling unit, that is basically controlling the flow of the cooling agents, that is to each of the battery, each battery cooling plate. Then we've also included other auxiliary components as well, including the fire suppression system as well, that is a very robust fire suppression system, and also a number of sensors as well, that is basically aiding the functionality of the auxiliary components in that is in the DC cabinets. And also, the other thing is that we've also tried as much as possible to improve on the safety by having this battery pack being IP67. We've also given the alternative, or rather the option of also having the fire suppression system up to the pack level. This is usually an option. This is usually a solution for our Santera units, but we've also given this as an option for our Sun Giga battery energy storage systems as well. Then also the material also that we use for the casing of the batteries is usually special fireproof material that is basically, it allows for a prevention of thermal runaway. Just in case it happens, it doesn't affect the adjacent battery pack as well. And the other thing that we look into, we've tried to have efficient thermal management system, that is because of the liquid cooling system as well, and we ensure that the maximum temperature difference between, or rather the highest and the lowest temperature is actually less than 2 degrees, that is 2 degrees Celsius, because of the efficient thermal management system. And the other thing is also the fire suppression system, which is actually robust with a number of sensors. There is smoke sensors and also temperature sensors as well. It's also compatible with Novec 1230 and also aerosols. So we usually give these as alternatives, and we can also customize based on the customer's requirement and also the local requirements, if there is any local requirements. Like in some instances, maybe FM 12 200 is basically required, and then we can customize based on the local requirements. But as standard, we have these as aerosols or Novec 12 that as well, with a number of sensors to also back up this fire suppression system. And the other thing is, if you look into the other main components, that is the power conversion system or the PCS. We have the PCS being the central component. This is basically the hybrid bidirectional inverter, which has an inbuilt static and fast switch, and also the isolation transformer as well. The isolation transformer. Then we also have other components, including for DC couple systems, we have the DC-DC converters where we can directly connect the PV modules. This is basically the MPPTs, that is for a DC couple system. For an AC couple system, we don't usually provide the DC-DC modules. Then we also have the energy management system as well. We also have the DC confluence cabinet. This is where we can now connect the different DC cabinets, that is from the Sun Giga cabinets. Then we have the energy management system, like I mentioned, and also the UPS for provision of auxiliary power. And the good thing is that we also provide, that is all the connection accessories, that is for connecting the PV cables, that is the DC cables from the batteries, the auxiliary cables as well, and also all the communication cables to be able to integrate the whole solution of the whole microgrid solution. And just to show you a perspective for a typical microgrid configuration, we made it in such a way to be able to address most of the challenges in most of the microgrids, which is basically the scalability of the system. So the one unit is actually 215. That is for the DC 1000-volt system is actually a 215 system, and we can expand up to n number of systems. So we can have in one microgrid, we can have, let's say, one PCS. With this one PCS can actually range from 100 kilowatts to 1,000. That is 1,000 kilowatts, or rather 1 megawatts. Then we can now have this connected to either one battery. We can have two batteries all the way to 8 batteries for systems less than 250 kilowatts, or we can also have up to 10 batteries for systems more than 500 kilowatts as well. So you can see, you can easily start in from one system of 215, then you can add in later on, that is add another battery cabinet of 215 up to n numbers. So you can see in this case, when it comes to the expansion or the future expansion, it's much easier compared to even Jinko's previous air-cooled energy storage solutions, where expansion was basically a limitation that we also witnessed. Then, of course, we have the DC busbar, which is basically in the Confluence cabinet. These already provided in the DC Confluence cabinet. Then we can have the output of the PCS at 400 volts, that is low voltage. Then we can also have this provision also for the step-up transformer to medium voltage distribution as well. And the other thing is that just to show you the standard configurations that we have, that is combining now the PCS, which can either be 100 kilowatts, 150 to 50, 500, and all the way to 100, that is 1 megawatt. Then we can have the combination of Sun Giga, which can either be 1 unit all the way to 10 units. That is basically the units connected into one PCS, and you can have multiple configurations. So because we are going to share this presentation, I don't need to really explain so much of this because this is basically our standard solutions. And we've also, tried to cater because of the different application scenarios. We can have this as these scenarios where we can have a DC couple where we make use of the DC-DC cabinet or rather the DC-DC components, and we can have this through PV combiner boxes, and we can have a DC couple system. And we can also have the scopes of generator, grid, and ATS. This is usually the EPC scope as well. But as Jinko, we can actually supply all the components on the ESS part, that is including the ancillary equipment and all the connection accessories. And the other scope to actually be provided by the EPC as well. And when it comes to the AC couple scenario, we've also given this flexibility, and the flexibility in that we can be able to integrate with any PV inverter that is basically available in the market, for as long as we know the communication protocol and we also have the register map. Then we can now embed this into our EMS for purposes of controlling the PV inverters. And we see in this case now, we'll only have in the PCS without without the combiner boxes, and the PV is actually connected on the load side of the PCS, that is through the PV inverters. So the monitoring is also still provided, that is using either mobile applications. You can see in this case on the left hand side, we can also have web-based monitoring as well. That is web-based monitoring, so that you can be able to do real-time monitoring as well. You can also be able to check the alarms that is from the microgrid system. You can also be able to check on any events. You can also be able to check into historical data, and also be able to generate reports as well. That is performance reports from the system as well. And this is basically some of the microgrid projects that just to highlight a few that we've implemented in the region, including Nigeria. We have Kenya as well. We have Uganda. We have Zambia. We have Mozambique, just to name but a few, including also DRC as well. Like in this microgrid project comes in that is in a 40-foot container that was implemented actually by one of our key clients, that is Paras Energy. I think we have Mr. Adesh today in this panel. You can see with the PV and battery energy storage equipment. Then we also have other projects as well. I think these also in different countries, in Kenya, in Nigeria, in Zambia as well. Then we also have other projects. I think this is also in Djibouti in 40-foot container with PV, with diesel generator, with battery energy storage, and also with grid as well. And we also have other Sun Giga DC cabinets as well that we've also implemented in other regions. So you can see now for this application where we have 2 units of Sun Giga to make it 430 kilowatt hours. We can also have 5 units to make it 1,075 kilowatt hours as well. That is to unlimited number of Sun Giga units as well. This is just to show you there is some examples of the systems that we've already implemented in Africa. So that is just the end of my techno-commercial presentation. So for more details about the Jinko energy storage solutions for microgrids, we can always get in touch. So this is my you can scan this QR code, you can get my contacts. There is email and also my contact phone number as well, so we can always connect. So just let me know if you have any questions. Thank you so much, and back to you, Ella.
Thank you so much, Mr. Titus, for that illuminating presentation. Well, it's now time for us to dive into the innovative realm of microgrid strategies and energy storage solutions tailored to meet the unique demands of such environments. Today, throughout the session, our esteemed speakers will immerse themselves in discussions on grid stability, scalability, and the future of off grid solar solutions integrated with energy storage. We'll explore pivotal advancements such as smart inverters and cutting edge control algorithms aimed at fortifying microgrid stability. Additionally, attendees will gain invaluable insights into Africa's power infrastructure, interconnection standards, and witness real world success stories of energy storage projects thriving in challenging conditions. Here, I would like to make a small announcement. Attendees can post their questions in the Q&A box, and our speakers will answer those questions at the end of the panel discussion. So, without further ado, please allow me to introduce you to our esteemed panel of speakers for today. We have Mr. Titus Coex, Senior Technical Service Manager, Genco ESS, Mr. Adam Terry, the Technical Director for Hamatin Renewables, Mr. Adish Kumar, Solar Business Head, Paras Energy Nigeria, Mr. Gabriel Croes, Head of Engineering from Empower, and Ms. Timothy Ajayi, Managing Director, The Frontier Solar Tech Limited, and Ms. Shitu Aflosed, Commercial and Product Manager, NG Energy Access. Ms. Shitu will be the moderator for the session today. Over to you, ma'am.
Thank you, Al. I hope I got the pronunciation of your name correctly. Kindly confirm that you can hear me, please.
Yes, ma'am, we can hear you.
Okay. Uh, Thank you so much. So we'll just dive right into it. In today's world, first off, I would like to welcome everyone to today's panel discussion looking at microgrids strategies and energy storage solutions for resilient power supply in remote and harsh environments. We all know that the demand for reliable power is increasing in geographically isolated and challenging environments, such as remote communities that are isolated and they have little or no access to critical infrastructures. So we have yet millions of people living in geographically isolated and challenging environments that remain without this basic electricity need. So the gap presents a significant hurdle to development and well-being. However, there is hope. Microgrids coupled with energy storage solutions are emerging, and they're emerging as a game changer. So without further ado, we'll dive into this panel discussion to explore exciting possibilities of microgrids and energy storage. So my first question will go to Mr. Adesh. We know that we understand that off-grid solar with storage offers great promises for remote areas. But how can these solutions address not only the variable natures of renewables, but also sudden spikes or dips in demand in isolated communities?
Yeah, thanks, Ms. Shitu. And I think a very valid question given with the African perspective. Uh, though I will try to cover from the Nigerian perspective, but this is very valid in most of the African countries. So, see, the major challenge now in Africa is not only the energy access, but the quality both from the grid side and let's say from the load side. Now, from the grid side, if the availability is almost like very low, so that's why now These microgrid solutions are available, although off grid or with limited grid solutions. So in case that's the best advantage, I'll say, for storage. And that's why when Title was talking about the scalability of the microgrid solution, it was very important, because what happens, let's say, in case the demand goes low or high, then one of the major application that comes for the storage is the energy whatever is being generated through solar, or let's say if limited grid is available at the time, we can store it, and then when the demand comes up, they will meet the expectation. Now, talking about the technicality, we should also think from others perspective. Like in Africa, I'll say on the technical side there are three major issues. The first one is obviously the grid quality and the stability, along with the availability. And the second is the environmental conditions. So I'll talk about more, or maybe my fellow speakers will talk about the environmental condition, like the humidity, temperature, and obviously in Nigeria and other West African countries of dust, like harmattan comes in. The third and most important is again from the O&M perspective, and that's where what I'll say the most important point of a storage system comes up is the modularity. So storage is modular. Let's say we design a system considering a demand, a micro system considering demand for let's say for 1 year or 1.5 years. But these solutions last for almost, the storage nowadays lasting for more than 10-15 years, and solar PV modules are lasting for almost 25-30 years. So in that case, what happens? Let's say after 2 years, the demand increases. Then, because of the modularity into the solution, you can always have an option to add more PV modules as well as more storage units. So that will ensure that at least the demand is met. And the second thing, whatever spike or the peak is coming, that can be catered to. You know, one of the application is the peak saving for the storage. But obviously the modularity is again important, because you don't know what will happen after 2-3 years, where the solution where we are designing is of 15-20 years. So I think going forward, because earlier the storage was not very popular because the technology was not mature. Now with very mature technologies and all those, though it will be covered up, I think by my fellow speakers, but because of the technology, I'll say one point, because of the scalability, and third is the flexibility in the solution. Storage along with solar, you will say, or maybe with the limited grid, is the best solution as of now for most of the African countries. Mosquito. Thank you.
Thank you so much, Mr. Adesh. I understand the fact that, I mean, there has to be room for growth from your conversation. Going on to Mr. Gabriel, I would like to say, what key technical challenges in integrating microgrid system with existing power infrastructures have you faced, and how can they be addressed? So, what key technical challenges in integrating microgrid system with existing power infrastructure have you faced, and how can they be addressed?
Yeah, I mean, can you guys hear me okay just before I go? Take good. Okay, so I think before I get to talking about the technical challenges we face, one of the things that Adesh touched on is the flexibility of storage solutions in general. And in the flexibility, it also poses a challenge and a risk. Which of these business cases or ways of operating do we choose to operate in? And we've often found that our clients will want a battery to do everything and everything at the same time. So a large part of the work that we do on a day-to-day basis when dealing with clients is education in the industry. And although the technologies have matured, and you're correct in saying that, from a safety perspective and from a scalability perspective, I think there's still an off-taker or client maturity that needs to come with us in order to increase the uptake of this. And in that, the challenges are often related to what the expectations are from the client, and making sure that we capture that the problems that we are trying to solve, and in some different scenarios, the problems are whether it's grid stability, as an example. There's frequency or voltage fluctuations in the grid, or in the load, and you could solve that by adding a battery, but you could also solve that by doing a number of other items. If the problem is not having access to power, or there's long outages, or there's simply no grid available, then it's a different technical problem that you're solving, and a different mindset or different solution needs to be applied in order to solve that problem. And something that we see very often is, I get to many clients that that they say that I'm the fifth, sixth, or the 10th person that has come to them with a battery solution, and then I often ask the question, why haven't you gone with any of the other guys before? Why didn't you actually do the project, if there were so many other proposals? And the answer, the client often doesn't understand it. They won't give me the answer, but when I get to the bottom line is that none of the other proposals solved or understood their problem. And I think as an industry, we need to step away from selling products, and move into a place where we are selling solutions. We need to be fixing problems. And that can be done by a number of different ways. And I know Titus mentioned, some of the really nice tech that they've developed as a company. DC to DC coupled switching, which fixes some of the challenges that customers have when switching from on-grid to off-grid mode. Because with DC to DC, you don't have any switching times; it's all direct online all the time. So that can be a solution for a problem, but it creates a single point of failure potentially if that DC to DC conversion is off. We have a system operating like that at the moment, then the whole site is down. Where if you have a system that has AC coupled parallel power sources, you have multiple levels of redundancy that you can build into that, and the site can be powered from different power sources, and if one of them is down, you don't have that single point of failure. So the point there being that no one of these solutions will be right for all of the different challenges that we face. Luckily, as an industry, before I go further, I also want to say that we often talk about innovation in the technology space, and we talk about challenges in the technology space. But I do want to say that there's also, I think we need to put time aside to talk about innovations in the business case space. Sometimes putting a new business concept together, a different way of modeling this or a different way of operating the asset, from a financial perspective, can result in creating different revenue streams or unlocking opportunities. What is key then is to make sure that the technologies can actually operate in this way that it was designed to meet the business case requirements, because there's no point you develop a new business case that has certain parameters or acts or responds to different weather or market costs, and then the technologies can't operate in the way that your business case operates. So these two have to be developed in parallel, the business cases and the technologies, in order to make sure that you can get the most out of this asset. So luckily, we've got very, very smart tools and some smart people. Some of the tools, with AI that's coming on board, the forecasting and the optimization of these assets to get to a blend of how much solar or batteries you need to use. Is it cheaper to run my generator, etc., has become a lot easier, and the forecasting can be done a lot more more accurate, which is really something that enables and empowers us as a developer or the EPC to get to a solution that suits the client's needs, and optimizing that from a cost and operational perspective. So I think with that, I'll hand over to Adam, who seems to be wanting to add to this. So thanks. That's me for now.
Yeah, I
Yeah.
see that Adam is interested in this conversation. Please go ahead, Adam.
So yeah, I think Gabriel raises a really interesting point there. There is this idea that a battery system can be made to solve all problems. And I think there is a lack of education. So it's something we've worked a lot on with lenders, with financing parties, to go around and educate people as to the use of the system. But fundamentally, one of the big things that I think, which is really nice to hear coming from Gabriel as a solution provider on this, is that I'm sick of an industry where people are trying to find problems, make the problem meet the solution, i.e. they've already got a predefined solution and they're trying to find find a way in which the problem then fits that solution. And actually the solution needs to be flexible and accommodate and meet the problem and actually address the needs. I think you've touched on one of the most important things that I see for the problem with microgrids at the moment, and that is actually proving that they're a better system, particularly from an economic performance compared to what people are used to with diesel. And I think this is one of the big challenges that we face in a renewable generation dominated industry, is that because of that intermittent nature of those generators, coupled with the cost of storage, I think what the biggest challenge we face with microgrids is actually making them cost effective. And one of the fundamentals off the back of that is, you need to put a value on the benefits that energy is bringing to an area if it's improving energy access, that are not necessarily purely fiscal. Because a lot of these systems, and again, Gabriel made a point about, if you've got a single point failure with a DC-DC coupled system or an AC coupled system having redundancy, all of that is more cost. We can build these systems, and we've seen examples in the industry whereby, basically the more technologies you incorporate into a microgrid, the more cost effective it is, because you have more of a balance of different techs. So I think saying, we've got a wonderful battery, great, it's a part of the system. We've got a wonderful solar product, great, a part of the system. If you can couple that with wind, if you can couple that with some hydro, if you can couple that with some thermal, diesel generator, the more technologies you bring to a system, the more resilient it is and the more cost effective it is. We've seen examples where we've had pure PV and battery storage systems, and they're massively oversized in order to meet demand. And that's just not a sustainable way of an economically sustainable way of doing business. So I think that's one of the things that we really need to change the mindset on. And actually it's quite useful when you're dealing with the DFIs, is that they are valuing more some of their socio-economic benefits of improving energy access than anything else. When I at a previous employer, we talked about a microgrid system for a village, and we were looking at it, and it's like, actually the benefits there are, you're bringing power, you're bringing communications, you're bringing education, you're bringing healthcare. All of these things come off the back of it. They don't help the pure business case in terms of the raw financial numbers, but they do bring significant economic benefits to the project and to the region. And that really needs to be a factor that's considered in a lot of these projects, is why they're happening. So it's not just what are they trying to do, why are they trying to do it has to be considered in the business case. Thank you, Shita. Back to
Yeah,
you.
Adam, I think that speaks to the comment I'd say, what problem are we solving? And if energy access is the problem, then you can't want that solution to compete on a cost per kilowatt hour basis with typical grid tariffs. It just doesn't make any sense. So yeah, on to the next speaker.
Okay, thank you. I mean, that's very salient points raised. We have to, just like Gabriel said, we have to not just think about selling solutions. We have to think about fixing the problems. And I also heard that Adam reiterated that. I mean, not working from the solution to a problem. It should be working from a problem to a solution. Thank you. So, with respect to some of the points about AI, Titus, I would like you to go next. What microgrid integration challenges do you see posed with communication and control, especially when integrating with existing infrastructures? Have you seen any cybersecurity considerations that you'd like to expatiate on? Thank you.
Yeah, I think for the last, we started ESS or ESS business close to 4 years ago, and we've not witnessed, we know we put in relevant measures to make sure that we don't get into any cyber attacks, and we've also had service in for that is for our RMS in different regions, mainly from China in Europe as well. We currently working with some other servers also in US, and probably very soon also looking at some also hosting our servers as well in Africa as well. So I think from an OEM perspective, we put in necessary measures to make sure that we don't, that some data is actually very sensitive, and but I think this is more sensitive when it comes to let's say grid or other utility applications, where grid data and also grid stability is very important, and we try as much as possible to be able to protect that is the data that is from the microgrid applications, or maybe even for the utility energy storage solution as well. So I don't think from our own perspective, from an OEM perspective, we've not had any challenges so far.
Are there strategies that you have, put in place to secure the microgrid system with energy storage against any potential cyber threats?
Hello. Yeah. So as an OEM, we've actually implemented that is multiple layers of data protection, and also we've also incorporated there is artificial intelligence as well to make sure that we can actually protect our that is the data that is for the different base applications. So, like I said, we've not had. I think we've only witnessed globally that I know. I think there is only be one case. I think there was in US, but there was some time back. But so far in the region, we've not. With the current measures that we put in place, so we've not really encountered any such challenges.
Thank you for your response. Uh, Adish, I would like to come back to you. I would like you to talk about some, case studies or success stories while integrating grid stability. It's always an invaluable means of learning when we share stories, especially how we are able to, analyze or overcome specific environmental challenges that we faced while running a project. So, with respect to microgrid and, of course, energy storage design, how have you been able to address any issues that you've come across? So, just share with us any of your success stories, using these case studies. Thank you.
Thanks, Mr. Itu. So before I jump into the case studies and why it was a success, Gabriel and Adam touched actually very, very relevant points on any project will succeed only if you will try to solve the actual challenges of the customer rather than just going forward with any fixed solution and try to sell them the solution. So rather than just making anything, you have to understand what customization has to be done in your solution so that it actually meets the challenge. Second important thing, what Adam was talking about regarding the microgrids is it should be cost effective, obviously. So unless and until it makes some commercial sense, so for industry, let's say from CNI perspective also, or from a microgrid perspective where you are supplying to the community where they don't have electricity at all. You need to understand the affordability of the people. So it's very easy to design any renewable storage solution with too much technicalities, uh, but unless and until you are actually making it cost effective and affordable to the end customer, it will not make sense. So, taking these 2 points, I'd like to first share a case study where we actually provided a complete off-grid solution to a very remote area. In Nigeria, it's very difficult for you to access some of the areas. Now, I'm talking about a client. It's a government company which was in near Benin city in Nigeria. That customer had installed. He was running a factory that was actually producing the LPG cylinders. So these cylinders, they're actually manufacturing the cylinders. He spent so much money to get a dedicated line from the grid. And what happened, because the area was not good, they vandalized the complete line. So after spending so much money, also he was not getting the supply. So plus he also want to make sure that if he so the challenge that he had is not only that he need electricity, he actually needed to solve small issue of the nearby community so that they'll also be happy and they help him to grow the business. So what he came to us that, okay, this is the challenge we had. So we proposed a tailor-made solution to him where we actually not only installed solar PV modules along with some storage, and the size was almost 1 megawatt storage with scalability up to 1.5. And the same thing was went to the storage system. The storage size was 1080 kilowatt hour. So what we did is, okay, the challenge what we had is the accessibility and to take the local manpower along with you, along with us, to get the solution ready. So we employed some of the local people. We involved them in getting the project ready. And then once the project was ready, we actually provided some of the electricity to the nearby community area through this solution. Now, the benefit it added is like, okay, first to the industry, it actually provided the much needed electricity where they were running actually this diesel gens before. So now, obviously, with the diesel gen cost, solar plus battery with the correct optimized sizing, it was much optimized in the cost. Second thing, when we involved and provided electricity to nearby community, they also got involved, and the response was so good that not only from the electricity perspective, from the other the business of the customer, they were also getting benefit because this solution was helping them to at least have electricity. So you understand there was no electricity at all in that area, and now along with the industry, some of the areas, some of the communities also getting some electricity, though that is not as per the expected demand, but yes, at least they helped them to solve some problems. So CSR activity was done, industry was getting the supply, and everybody end to end, end of the day was at least delighted such that they have some electricity in mind. So this was very good case study. We find it very relevant with respect to West African environment, where if you want to set up industry where you are getting the raw materials at the same time, same place, rather than setting up an industry where you are having the infrastructure, but the cost of getting those goods and everything is very expensive. So that was one. The second case study I would like to share is an industry that was making a blocks, cement blocks, the paving blocks. And though it was in the city side, it was almost 50 kilometers from the existing substation, the grid substation, and was nearby to the sea. So they faced the challenge that, okay, the corrosivity and all those were very high. Whatever equipment they were installing, they were being damaged very fast. When we talk about some of the metal structures and all those. So then we had to think from that perspective that, okay, whatever solution we are providing, first of all, it should last for another 15, 20 years. So structure, design, all the everything, earthing and all those, we kept in mind while designing it. From the technical perspective, that is very, very important. Second thing, the peak was very high, although the average demand was very low. So that's why we had a little bit higher capacity PCS with very optimized battery solution. So the size was 945 kilowatt hour storage along with around 900 kilowatt PV. We also provided flexibility of adding grid in the future if they want. So they were also running the complete plant through diesel generator. And whenever there was shutdown, like any issue in the diesel generator, the complete plant was shut down. So now they are like, it's been more, I think, almost a year, and they never had such type of outages. So from the engineering perspective, yes, you have to understand where you are going to install, what kind of challenges the customer has. The second important thing is from the O&M perspective, we also have to understand that the system, whatever we are handing out to the customer, should be very easy, okay, and anyone can easily able to at least operate it. So now the solution, we took it from Jinko actually. So Jinko provided a solution that was more or less means auto, like working on auto. They even we installed some system controller that can actually control and start the DG whenever the grid was available. Sorry, the solar was generating, it was taking the power, and then whenever it was not available, it was stored into the storage, and everything was on auto mode. Yes, we have people there, but only cleaning the panels. So that is also very important from the O&M perspective, that we what we provide to the customer should meet the requirement, because technical know-how in this area is not as compared to the other developed countries. So that is one of the perspective. Like whenever we an EPC company design a solution, they mostly don't think from a perspective of having the solution lasting another 10-15 years, and O&M perspective also, that it should be very, very easy for the customer or anyone who is maintaining it. So these were the two case study. I think my other fellow speakers can also add, but yes, what Gabriel and Adam was telling, that okay, it is very, very important to understand what is the real challenge and what we need to provide to the customers. Thank you.
Just a very, very quick comment on that, if I may, before we go on to the next speaker. It would be useful to know, and this is probably addressed to Titus to some extent, is that how involved does the OEM supplier need to be in the design process? And the question is around responsibility, because I've found, and we've had challenges where there's the design of a system for a solution, and at the moment all of the risk sits with the EPC. So we need to come and sort of bring all the different components together. When we go back to a client and the solution isn't working the way we hoped it would, a lot of the times it's because, in our view, the components that we've used, the hardware, the batteries or the inverters, aren't doing what we feel they should be doing, or what their sort of nameplates are saying, or what their data sheets are telling us that they can do. So this question is, should the EPC involve the OEM supplier, somebody like a Jinko, in the early design stages of the project to validate the designs or review the designs or confirm that the designs can actually do what we would like the technologies to do before we as an EPC go and build or propose that as a client for a solution?
Yeah,
Citus
just
up.
yeah, just to respond to Gabriel. I think there is a very important point, and we've also noticed, the case studies that Adesh was actually mentioning. I think we really work through the whole design together. That is, ever since the project inception, we were always having discussions to see, okay, what the equipment can do. And I think also, was it Gabriel or Adam mentioned earlier on, that we need to demystify this fact that we think that the solution from OEM can actually do whatever you want it to do. The thing is that you have to make sure that you define your problem statements. The challenges that we have as an OEM nowadays is even getting information from our partners or our clients with regards to the project information. We don't have rather problem statements. We don't have information of what is the application scenario. We also don't have information about what is the load scenario as well, what is basically the requirements, what is the operational methodology as well. So I think it all falls into the designing phase of the project. I think that is why we need to go back into the previous concept of having project consultants. We need to have there is partners like the likes of Amatan Renewables. It can actually advise you that yes, you want to choose this solution, but this is basically what you require based on the client's requirements. But the thing is that nowadays we are leaving all the problems to the OEM. So the OEM formulates the problem, then gives the solution, which that way I don't think is basically going to be workable. It needs to be a multi partner approach where you basically able to discuss and agree that this is the problem. Then you define there is basically the scope of each of the parties. Then you also formulate the solution. There is the OEM now, which includes Jinko can now say, okay, this is what we can do. This is what our equipment can do. This is what our equipment cannot do. That is knowing that what the equipment cannot do is very important, so that okay, what other thing do you need to do, whether you need to engage another party. Let's say you need to engage another EMS, another controller, or another equipment to mitigate what the OEM's equipment cannot do. So I think that has to be it has to be very clear that is from the word go. And you see, the other thing is that, let's say I would give another case scenario, just to add into what Adesh was saying earlier on, that when they were designing the equipment, the design was actually a design for 1.3 megawatt hours. But because of the budget constraints, they started with 900 kilowatt hours. But you can see that in the initial design, the scalability aspect has actually been factored in, so that even later on, if the client, which is basically Paras, comes to Jinko, they want to expand the solution, it will be very easy because the software is actually already developed. The hardware provision is also provided as well. So it's very easy to just expand the solutions to that is to the required capacity. So I think I just wanted to agree with Gabriel that the OEM, it is very important to engage the OEM from the word go, so that you have common understanding and to, of course, avoid issues of warranty, that is warranty claims in the near future, and also so many complaints from the end users.
Yeah, so I think if I jump in on that, actually, one of the expressions that I quite often use for clients is that it's all well and good buying a Rolls Royce, but if the person using it has never driven anything more complicated than a Honda Cub before, it's not going to end well. So you can buy the best equipment in the world, but if you use it in the wrong way or a way that it's not designed to be used, it's never going to be a successful project. And I think while to an extent, standalone PV systems, standalone wind systems, you can get away with that to an extent. I think the problem that we're seeing is that batteries. Yeah, I'm gonna mention the two dreaded words, degradation and augmentation. Batteries are sensitive creatures to an extent, and how you use them is really important to the life of them and the economics of your project. And I think that's where you start to come back into needing to understand how you're going to use them and making sure that you've got the right solution to the project. We see people whereby there's been a lot of cases in South Africa and beyond where people have bought batteries and then they've found that they've used them a lot more than they planned on. And so people are having to replace battery systems after 5-10 years maximum, when they had a design life of 15 to maybe 20 years. because the use case isn't managed. And I think that's one of the areas that I'm really excited to see how improvements in controls and AI and machine learning can really become important to understanding the operation of the system. And again, it reinforces why I say that we need different technologies. Because, if you know that you've got a prolonged outage coming up on a system, you don't really want to necessarily be draining the battery. At that point, you might find that it's more advantageous to fire up the diesel generator for that period to get you through it and maintain the battery to manage the spikes in power demand and generation. Just picking up to close out one of the points also that Adesh raised, which was actually really nice to hear, is that we're seeing a lot more people who are building projects trying to bring in the local community for construction, and also to provide benefits to them. And it is a challenge. We do see issues. Sometimes the labor is very unskilled, and so it can be a challenge. But actually, it ties back to the previous topic, which was around security. We mentioned security, and I think actually at the minute, most of the projects that we see are more of a physical security risk than a cyber security risk. Although I would say to anybody going ahead with a microgrid system, the IEC does have 62351 as their cyber security standard. And so that's something whenever we're advising clients on, that we need to make sure that the system design incorporates the principles of that IEC standard, because that IEC standard has been brought in specifically for energy power plants. And primarily that has been learned from lessons in areas of conflict such as Ukraine, where there have been grid infrastructure attacks. It's not really an issue yet, but it wouldn't take an awful lot for somebody to start attacking these systems. But I think at the moment, like I say, the main issue is more if you can get the local population on side, provide them with some benefits, then you'll find that the site security is better physically, and your plant performance and operation goes up. But like I say, there's a whole bunch of different things coming up together in one here that all needs to be factored in. Thank you. Back.
Quite agree with your last statement, Adam. I mean, besides the issue of cybersecurity, physical security is actually a threat, especially looking at remote communities where would really like to deploy most of our solutions, because they are actually the ones that really need more of energy. I mean, you would agree with me that it is evident that access to reliable and clean energy is not a luxury, but it's a necessity. So I'm glad that we are having this conversation, and I'm glad that everybody is bringing our points. So we're all aligning together as the OEM, as the service provider, as the technical person. Thank you so much, guys. So moving on to Timothy. Timothy, you're welcome. I mean, I would like you to speak about harnessing energy storage for microgrid resilience. But I would like you to also put into consideration in your conversation storage beyond backup, how you size the solution, and of course, do you consider second life of your batteries? Thank you.
Okay, so thank you very much, Shitu. Thank you for that. So I just want to, let me briefly mention that, energy storage is a very important device, and it's a technology that is helping advancing energy access in the rural areas, not only in the rural areas, even in the urban areas as well. So when we consider when we look at the mini grid value chain in general, we will see that the role of energy storage goes beyond um, backup, because if we are to look at energy storage as a backup device in the mini grid value chain, it's it means that we have to look at only the time, or the time of use, or a particular time during the day, when a certain supply or a fraction of energy supply will come from energy storage. But it goes beyond that. It goes beyond that in the sense that energy storage is also a resilient device. It provides energy resilience. Energy resilience in the sense that if you look at the renewable energy technology in general, we see that the generating source is not a source that is actually within the human control. Let's take solar technology, for instance. Solar technology has a lot of limitations that are attributed to, fluctuation in the weather, the irradiation from sun, because the irradiation from sun is not uniform, is not regular throughout the day. Weather, cloud, a lot of moving objects in the space can actually determine the quantity or the amount of irradiation that we receive on the surface of the earth. And then, so the amount of irradiation from sun that we receive on the surface of the earth actually determines the energy to sunlight conversion rate or ratio, as the case may be. And so when we look at this factor, we discover that relying on solar as a source of electricity will actually pose a lot of challenges in meeting energy supply. In meeting energy supply, like what I mean by energy supply is that there has to be a kind of agreement between demand and supply. So demand, which is from end user side, and then supply, which is from the local grid operator or the supplier side. So when the supplier is not able to meet energy demand, it means that there is a discrepancy. There is a lot of gap between this, and then it means that the system is not resilient, is not reliable, so it's not sustainable. For it to be sustainable, for it to be resilient, for it to be reliable, there has to be a kind of balancing, energy balancing. And that balancing can only be provided by a smart energy storage device that is able to communicate the energy management system in place. So, what I'm saying in essence is that the role of energy storage, that is battery, in the mini grid value chain goes beyond backup. Actually, backup is a very important uh, factor to consider when sizing energy storage, because during the daytime, the supply is also almost tend to be very much greater than the installed capacity. So we need a kind of energy storage to be able to store that excess generation during the daytime. But that shouldn't be the only major reason why we look into battery and we look into energy storage integration into the mini grid design or mini grid value chain. So we also look at providing balancing, energy balancing. So that will be a time when solar is not able to, when solar PV is not able to meet the consumption, like a demand, customers demand. So when solar is not able to supply the total energy demanded by the customer from the consumption side or from the demand side, so this deficiency is going to come from energy storage. So this kind of approach will make a kind of a mini grid supply in the rural areas more resilient and sustainable, as well as it will also provide reliability as well. And again, when we also look at the entire mini grid value chain as well, we discover that if you say that you are going to provide a mini grid, like you are going to supply energy for a certain period of time in a day. So the availability of solar or the wind, as depending on the technology, that the generator or the supplier is applying or is using for that particular mini grid. So the availability of this renewable energy technology is very limited during the day period, especially when we look at solar. An average peak sun hour in Nigeria, like a quality sun that we can say, okay, that is reliable for power generation, is almost about 5 hours. And you want to supply power for almost 10, 15, 20 hours a day, then you need external device to support the PV or the battery. Sorry, to support the PV or whatever technology, whatever renewable energy technology that is being used as the primary source of electricity. Now, storage is among them. So when we look at storage, then we will also have to consider like the number of hours. So when at this point, we cannot be saying, okay, the backup time is being considered. And then when we are looking at backup time, you look at, if you look at the cost of battery, the cost of battery is very, is almost very high to say that you want to run on battery for like a 5, 6, 10 hours. It will make the mini grid financial model not attractive to investors because of the high cost of capex. Now, so for us to do that, we also need to bring in additional source of electricity that can provide instant power supply. So that's why we also look at diesel or gas generator in the case. So when we are bringing in diesel or gas generator to support the solar PV as the primary source of electricity, then your batteries should also be able to store the excess. So it should also be able to provide backup during the time when this diesel generator is being supplied the load. Let's say, for instance, there is a device or there is a mini grid that we are currently looking at. So the OEM, they came up with their single line diagram, their solution, their offers. So we discovered that during the daytime, solar and a battery will power for like roughly 8 to 10 hours. Then throughout the night, only diesel generator will supply the load. I say, no, that is not sustainable, because the battery is also sized to reduce the generator runtime or to reduce the runtime of generator, so that during the time when generator is supplying the load, it has to do both load supply and a cycle charging, like a load following and cycle charging. So in the load following and cycle charging design structure, during the time when generator is supplying, the battery should also be able to store part of the generated electricity for backup purpose. So what am I saying in essence is that the battery or integrating energy storage into mini grid value chain simply provides both energy balancing and backup, and also reduce the runtime of generator, so that the mini grid can also reduce their CO2 emission into the atmosphere, while providing their sustainable electricity in the selected community or areas. Hello.
Thank you for
Hello.
your. Can you hear me?
Sorry, you are muted.
Oh, I can hear you loud and clear.
We can hear you guys. Yeah, go for it.
Yeah, so that's the points I have for now. If there is any question around that, then we can look at it together. As I know that we are a group of professionals.
Yes, I know. We have a couple of questions in the Q&A which would very soon get off, but due to lack of time, I just have I would like Adam to just quickly look at, we are talking about off-grid solar solutions with energy storage. There's a potential to revolutionize the energy access in harsh environments, but scalability and future outlook are crucial considerations. So how do you see the scalability of off-grid solar solutions with energy storage evolving in the future?
I think at the moment that it's a market driven by DFIs and NGOs funding these sort of projects. I think that for the most part, the natural drivers in the market are tied around an industrial base. So obviously the biggest users of these sort of off-grid, microgrid type solutions have been mines and other energy intensive industries that are tending to be a long way away from population centers. I think technology wise, I think the hardest challenge to overcome, and referring to Timothy's point a minute ago, the hardest challenge to overcome on these projects is um, understanding how we deal with long duration outages in terms of generation. And I think, we worked on a project where actually the whole reason why the microgrid or the renewables driven microgrid with PV and storage was coming into fruition was because actually um, the microgrid that operated on a purely diesel genset basis was coming to the end of its useful life in terms of the diesel gensets were um, had reached a point of high unreliability. And so the economics didn't make sense, or the investment case for investing in new thermal, new diesel became quite challenging. Um, I think the biggest factor that we're probably overcoming at the minute, though, is still the fact that how long and how resilient the microgrid systems are, and that's why earlier on I was making the comments about bringing in multiple technologies, bringing in advanced controls, and making sure that that the solution really is tailored to the issues in hand, is because all of this is to make a longer term solution to the problem. I think when we start to look at it, people are now beginning to question how long does a battery actually last, and that's fundamentally, I've been working in the energy storage industry for 10 plus years, and the renewables industry for over 20 years. People understand how a renewable system degrades. People are now getting their heads around how a battery degrades, but even then it's still very variable because it comes down to the usage. So the more that can be done in terms of understanding that and optimizing that through smart technology, through that resilience of different technologies, I think that's really critical to a wider scale rollout. It's been a case for the last 10 years that at some of the big DFI conferences across Africa, there's always an assumption that microgrids is going to be a significant factor. There are some countries where microgrids are expected to make up 50% of the grid infrastructure in country. So it's going to be one of those solutions that has gained more acceptance. I think, like I say, the challenge will be making sure that it is a robust solution, that we're not here in 5, 7, 10 years time finding that these microgrid systems are falling over or are costing us a fortune more than people anticipated because batteries need augmenting or the reliability of the systems have been poor. Um, so I think there's still a lot of lessons to learn. And hopefully there's a lot of progress been made in addressing them. I think technologically we're improving a hell of a lot as an industry. But I think realistically we're still back to that fundamental point at the outset is making sure that you're tailoring the solution to the problem, not trying to make the problem fit the solution. So the better we get at that journey, then I think the more success there will be for the industry across the continent.
Thank you, Adam. Thank you all for your active participation and insightful contributions to today's discussion. It is clear that we've only scratched the surface of this critical topic because of time. But I hope we've sparked meaningful conversations and connections that will continue long after this session. Uh, a key takeaway for me from this conversation is that we have to fix a problem more than selling a solution. It's very important. And I mean, if I don't take anything away from this conversation, that is very, very important. So while we'll wrap up, there are some questions in the Q&A that I would just read out, and then anybody can go for it. So there's a question here for Titus. It says, if the water is used as a cooling system for electronic equipment, how do you solve the moisture accumulation problem?
Hello, Ashiru. I'm not sure. Can you hear me clearly?
We can.
I can hear
Yeah,
you loud and
yeah,
clear.
yeah. So what we've basically done, this is something that we've factored in place, and we already put in dehumidification systems that is inside the battery cabinets, and also we've incorporated a number of sensors as well. There is a number of moisture sensors as well, and also ventilation system. So in any case, this will not really happen. And also, even if the dehumidification system fails, we've also incorporated there is extra protection, like of course the drainage system in case of accumulation of water inside the battery cabinets. So that is one of the protection measures. And the other thing is also, like I mentioned before in my presentation, is the battery packs are also rated at IP67 as well. So that is basically the different measures that we put in place to make sure that there is no accumulation of moisture inside that is inside the battery cabinets.
Okay, there's another question from Olubukola. She says, when installing a small inverter system, the infrastructure needed is little. Her question is, when having a mini grid, what kind of infrastructure are we looking at? Adesh, would you like to take that?
Okay.
Sure.
So infrastructure wise, yes, definitely the solution is completely different as compared to small inverter system, and there is no straightforward answer for this. The answer lies within what kind of solution you are designing. Definitely, what Adam was telling earlier, that the cost effectiveness will obviously come. So, but basically, let's say if you're designing a mini grid, minimum you need is at least some ground space for setting up the PV modules and the batteries, obviously, along with, in case now in Nigeria, and we was doing one mini grid in Republic of Benin, where diesel generator as a backup was must. Along with that, the other important aspect that we need to understand is how we are going to actually meter it. So revenue realization point of view is very important, because you are actually doing some commercial transaction, and you need to be very sure that whatever energy is generated, which is built, you are actually going to collect it as well. So distribution infrastructure obviously will be there, along with, nowadays, since very advanced smart meters are there in the market, the metering system would play a very pivotal role. So altogether, yes, again, we have to understand what kind of solution you are designing. There is no straightforward answer for this, but yeah, on a let's say, if you're considering any very basic microgrid, at least these are the infrastructure that need to be there.
Thank you, Adesh. This question is asking about funds. How can a startup company access funds to set up micro solar grid systems? Um who would like to go for this? Gabriel, Titus?
Oh, I can quickly comment on that. So we've seen, and I talked about different levels of innovation, and here I want to commend the various financing partners that we work with. Um, the ways of access to finance has changed significantly in the past couple of years, and we've seen banks being willing to lend money and take the asset as collateral. Um, the vehicle is more of an asset finance solution rather than financing a business case or an operation, because they've come to know that if they stop paying, they can simply go and pick up the battery container, and then the access to energy would not be there. Um, so banks would definitely be one way, and further to that, if the problem is actually, getting access to the battery, then perhaps access to finance is not the way to go about this, but that one would actually want to speak to another IPP to provide financing, to build and operate this plant and just provide, energy to the off-taker. If you are simply the off-taker looking for the energy, then perhaps it's not the best way for you to finance this yourself, and perhaps you are looking at solving the wrong problem if you are looking at financing this, or if you see the financing as a challenge. Perhaps your problem is simply access to energy and you need the energy, and you need to step away from that and make the financing somebody else's problem. So I think there are multiple ways to look at this. Our experience in the industry has been that there is tons of money to go around. We have investors looking for projects, so it's not that there's a shortage of money to invest in these projects. It's making sure that we again, answer or solve the correct problems by applying these, the capital or deploying the capital into the correct projects.
Thank you. The next question says, are we foreseeing improvements in solar panel efficiencies? If so, at what projections? And on the same note, what happens to solar panels after depleting their usefulness, say 20 to 30 years, I presume?
Yeah, let me take this because I think this is directed to an OEM. So I
Yes.
would say, you know, I think the last 5 years, the advancement in technology of solar panels has really been noticeable. We've actually witnessed the increase in efficiency from around 90% to currently where we are at almost 24%. That is around 23.8, 23.6 to 23.8. That is basically on the mass production efficiency. And also, we've also seen some records as well, like from Jinko, where we actually announced in Q1 an efficiency record of around 24.76%. That is for our N-type mono. That is our N-type mono modules as well. And also, there are also breakthroughs in other technologies. Just to say, we just came in from the monopack technology for the PV modules, where we are currently is on the N type, where we have basically mainly focused into the TopCon and the other technologies like the heterojunction and also the IBC as well, and also other future technologies like what OEMs now, the research labs are basically currently trying to do more research on, including technologies like tandem, where we've also tested as an OEM, and we're actually looking at approximately around 32% that is on the cell efficiency. So that tells you that the module efficiency would basically be around approximately 30%. That is in the next 4 or 5 years. So you can see that with the increase in technology. So, but at the moment, you see, it depends on how the market reacts to the change in technology. What I can say is there've been very good feedback in all the regions, even Africa, where there is great acceptance into new technologies. That is why in Africa currently we don't really struggle into selling our new technologies. That is selling TopCon in Africa, because we understand the importance of high efficiency in the PV modules. So even in future, that is in the near future, if we come up with, let's say, there is a technology change to maybe tandem solar cells as well, then that will also, I can see no add-ons, and we would basically see that there will be some acceptance into that is the newer technologies maybe in the next 2 or 3 years. So I would say basically, just in summary, maybe probably projections in the next less than 5 years, we might be getting to approximately 30%, at least 30% of mass production of solar panel efficiency. And with regards to solar panels, that is ideally, the warranties for solar panels, solar panels don't expire, but the warranties currently is a standard of 30 years. So we expect that at the end of 30 years, we would maybe would want to do a replacement of the solar panels. But what do you do with the replace solar panels? Do you just dispose? If you carelessly dispose, this is actually going to be an hazard to the environment. So there is also need for recycling. That's why you see that some companies, mainly like OEMs currently, like Jinko, we also trying to get into the recycling business, so that we can be able to assist our clients to take back the modules and also be able to do recycling as well. What I can also appreciate is that there are so many other companies that are also doing recycling in different parts. There are also organizations like PV Cycle as well that is also taking up the responsibility of recycling of the solar panels as well. So I think that is just my quick comment or other response to that particular question from Collins.
Thank you, Titus. That's so helpful. I like the fact that you ended the conversation with speaking about recycling, because as much as we are also trying to provide clean energy, we should also consider the environment. So, thank you very much. Thank you to each and every one of you on this discussion today. It was nice connecting with you. It was nice having insightful conversations. Thank you. Over to you, Ala.
Thank you so much to all our esteemed panelists and our moderator. Thank you to our audience. And with this, we have come to the end of this virtual event. A very special mention to Ms. Shitu for superbly managing the session and collaborating with us on this event. Big to our attendees for extending your valuable time, and a special thanks to our sponsor, Jinko ESS, for their immense support to organize this event. It has been a wonderfully insightful session, and as is proven by the number of questions we were asked and how interactive the panel discussion was. We promised you to come back soon with more exciting sessions. The floor is now open for networking. Thank you all.
Thanks all.
Thank you, everyone. Goodbye.